Okay, so picture this. You're a researcher, maybe a data scientist, and you've got this brilliant new idea you want to test. But there's a problem, right? The exact data you need, it just doesn't exist. Or maybe the data you do have is full of gaps or it's biased. Sound familiar? Well, what if you could just ask an AI to create the perfect spreadsheet-style data you need, right on command? Today, we're going to dig into a brand new technology that claims to do exactly that. All right, here's our game plan. First, we'll talk about the big problem with controllable data. Then we'll get into a flexible new approach that's shaking things up. We'll break down exactly how this thing works. It's called RelDDPM. After that, we'll put it to the test and see the results. And finally, we'll look ahead to the future of data. Let's get into it. All right, first up, let's really nail down the core problem we're trying to solve here. So have you ever needed data you just don't have? I mean, anyone who's worked with data knows this pain. You're trying to train a machine learning model, but your data set is all lopsided. Or you're trying to understand your customers, but huge chunks of info are just missing. And look, this isn't just a small headache, right? It can literally bring critical projects to a grinding halt. Okay, so the fancy term for what we're talking about is controllable tabular data synthesis. Now, the magic word in all of this is controllable. This isn't about just making up random numbers and throwing them in a spreadsheet. No. This is about creating high-quality, super realistic data that has to follow very specific rules. You know, things like only generate data for apartments that rent for more than $5,000 a month, or make me a data set that perfectly matches the demographics of this specific town. And this is where you can really see the big idea. See, the old way of doing this, it was kind of a nightmare. Let's say you built an AI to generate data about apartments. Great. But then you decide you want to add a new rule, like that rent price one. Well, guess what? You had to go all the way back to the beginning and completely retrain the entire model from scratch. It was so slow and inflexible. The new idea, the breakthrough, is to split these jobs up. You train one big model just once to learn what real data looks like. Then you use these tiny, lightweight controllers to guide that model with new rules, totally on the fly. So yeah, this idea of separating the learning from the controlling, that's the absolute key to this new, flexible approach. And it really is a beautiful two-step dance. Step one, you build what the researchers call an unconditional model. Its only job, its entire job, is to become an expert on the real data. It learns all the patterns, the hidden connections, everything. You can think of this as the raw horsepower, the big, powerful engine. Then comes step two. You bolt on these lightweight controllers that act like a steering wheel, telling that powerful engine exactly where to go to generate data that meets your new rules. So how does this whole system, RelDDPM, actually work under the hood? Well, it's a really clever combination of two main parts, something called the diffuser and the controller. Okay, let's start with that engine I mentioned, the diffuser. And the best analogy for this, seriously, is to think of it like a digital photo restorer. It's built on the super powerful type of AI called a denoising diffusion probabilistic model, or DDPM for short. So get this, instead of starting from nothing, it actually starts with a page of pure static, just random noise. Then, step by step, the diffuser intelligently starts removing that noise. It's like it knows exactly what's real and what's garbage. And after this process, what you're left with is a crystal clear, totally realistic data point. It's kind of like a sculptor who sees a statue inside a block of marble and just chips away everything that isn't part of it. It's pretty amazing. All right, so if the diffuser is our powerful engine, then the controller, that's our GPS. It's the smart navigation system that tells the engine where to go. This is the part that puts the control in controllable data. So let's zoom in on how this partnership works step by tiny step. Remember that denoising process? At each stage, the diffuser basically says, okay, I think we should remove this bit of noise next. But before that happens, the controller jumps in. It looks at your rule, like the rent has to be over $5,000, and it calculates this tiny little nudge, a course correction. The final move is a mix of the diffuser's prediction plus the controller's nudge. And this happens again and again, over and over, until you have a perfect data point that's not only realistic, but also follows your exact rule. It's brilliant. Okay, so theory is one thing,
But the real question is, does this thing actually work in practice? Well, the researchers put RelDDPM head-to-head against some of the other top methods out there to find out. And the results for training time, honestly, they're just staggering. Take a look. On a task using a heart disease dataset, a popular model called CTGN took almost 1,800 seconds. Another one, Restore, took over 1,200. And RelDDPM, get this, under 27 seconds. That is not a typo. And it's because it doesn't have to retrain everything from scratch. The main diffuser is already good to go. You just prep the tiny controller. We're talking about a massive, massive leap in efficiency. But it's not just about being faster. It's also about being better. Check out this chart. This shows how well the different methods did at fixing biased data. Higher is better, and, well, it's not even close. RelDDPM scored a 0.35, which is more than double its nearest competitor. This proves that this whole guided process isn't just a cool trick. It actually creates higher quality, more accurate data at the end of the day.
And really, the researchers' own words sum it up best. They basically said, look, our method doesn't just outperform the current state of the art, it's also super flexible and efficient, even with rules it's never seen before. And that last part? That was the whole point. That's the problem they set out to solve from the very beginning. So what we have here is something that's faster, more accurate, and way more flexible than what came before. So, what does that actually let us do?
I mean, what does this actually mean for the real world? What changes when you can create almost any data you need on command?
Well, the paper points to a few game-changing applications. First step, fixing imbalance in your data. So if you're studying something rare, like a specific disease or maybe fraud, you can now easily create more examples to build much fairer, more accurate models. Next, completing datasets. This tech can look at a complex database with missing info and just intelligently fill in the blanks. And third, and this one is a really big deal for privacy, is data sharing. A company can create a totally fake but super realistic dataset that looks just like their real private customer data. Then they can share that for research without ever exposing a single person's actual information.
And that's really the big idea I want to leave you with. This isn't just about making better spreadsheets. This is a fundamental change in how we work with information. Think about it. When the biggest obstacle, getting the right data, just vanishes, what happens then? It blows open the doors to a whole new world of questions we can ask and problems we can finally start to solve. If we can create any data we need on command, what problems will we solve next?